Section 6-4 are about properties of rhombuses, rectangles, and squares. So by the end of this section, you need to know the properties of rhombuses, rectangles, and squares, and be able to use those properties to write and then solve equations. You will also need to be able to find the missing measures in rhombuses and be able to identify which polygons have a given property. Okay, and there are 3 geometry standards that we'll be covering in this section. All right, to begin with, in this first video, I'll talk a lot about rhombuses. Okay, a rhombus is a parallelogram with 4 congruent sides. Okay, and I have 3 pictures of rhombuses down here. Now, typically, when you see pictures of rhombuses, especially one like this, in the past, you've called it a diamond. Okay, and although a lot of people use that, the true mathematical or the true geometric name for a diamond is a rhombus. Okay, and a rhombus is any quadrilateral or parallelogram with 4 congruent sides. Okay, now since a rhombus is a quadrilateral, it has all the properties of quadrilaterals. It has 4 sides. The sum of the interior angles is 360 degrees. The sum of the exterior angles are 360 degrees. And rhombuses are also parallelograms. And so it has the 4 properties of parallelograms. The opposite sides are congruent, which makes sense because all the sides are congruent. The consecutive angles are supplementary. The opposite angles are congruent. And the diagonals bisect each other. And there are 2 more properties of rhombuses that you need to know. Now the first one, I will demonstrate using a Geometry Sketchpad file. Okay, this is a rhombus. All the sides will be congruent. Okay, and I'm going to draw in the diagonals. Okay, and they intersect at a point that I'll call E. Okay, now there's several things about angles that I want you to know. Okay, the first thing that you may notice is that the diagonals are always perpendicular. No matter how I move this, the diagonals will always be perpendicular. Okay, and that's the first thing that you need to know. That if a parallelogram is a rhombus, then the diagonals are perpendicular. And we could use triangle congruence theorems and write out a proof for this theorem, but just for simplicity, I'm not going to. But you need to know that the diagonals of a rhombus are perpendicular. Now the second property also has to do with angle measures and the diagonals. Okay, if you notice that, let me just draw in the angles. Okay, as I move this around, these angles always stay the same. Okay. Okay, so let me kind of draw in where those angles are. Angle BAE is right here. And angle DAE is right here. Okay, so what's happened is that this diagonal right here has bisected that angle. Okay, so angle A has been bisected by the diagonal. Okay, angle BCE is right here, and angle DCE is right here. Okay, so again, it's angle C has also been bisected. Okay, also notice that these angles are also the same. Okay, angle ABE is congruent to angle EBC. So what's happened is that this diagonal has bisected angle B, and CDE is congruent to ADE. Okay, so it's also bisected that angle. The thing you need to know about rhombuses is that the diagonals will bisect the opposite angles. That's the second property that you need to know about rhombuses. That if a parallelogram is a rhombus, then the diagonals will bisect a pair of opposite angles. Okay, and again, we could use triangle congruence theorems to prove this theorem, but we're not going to. But we could. Okay, let's use these properties and to give you a couple example problems of how you would use this to find angle measures. So I'll call this problem 1, problem 2, and problem 3. Okay, now in problem 1, it's not very straightforward. You can't really find angles 2 or 4 immediately just because you know this angle is 106. Okay, but let me remember that a rhombus is a parallelogram. And because it's a parallelogram, the consecutive angles, the angles right next to each other, are supplementary. So this angle, angles 3 and 4 together, are supplementary with 106. So I'll subtract 180 minus 106 and get 74. Okay, so angles 3 and 4 together, that big angle is 74 degrees. Now, I just learned that the diagonals will bisect the angles. Okay, so 3 and 4 are being, that big angle is being cut in half by the diagonal, and angles 3 and 4 are equal to half of 74. And I get 37. Okay, so angle 3 is equal to 37, and angle 4 is equal to 37 degrees. Okay, now for the exact same reason, angles 1 and 2 together, that this big angle is also equal to 74. Okay, and the diagonal also cuts 1 and 2 in half, and so angle 1 is 37, and angle 2 is also 37. Okay, now let's move on to number 2. Now, in number 2, the simplest one to know is the measure of angle 2. Now, we just talked about the fact that the diagonals are perpendicular. So angle 2 will be 90 degrees. Okay? Now, using 58, now let me back up. Because this rhombus is a parallelogram, the opposite angles, this angle and this angle, will be congruent. Okay? And this diagonal will cut both angles in half, and so this angle up here will also be 58, and it looks to be about the same. Okay, so angle 3 is equal to 58 degrees. Okay, and also this angle right here is also 58 degrees, and we'll use that to find angle 1. Okay, so the angles in this triangle will add up to be 180 degrees. Okay, this one's 58, this one's 90. Okay, so I'm going to add 58 and 90 together, and I get 148. And I subtract that from 180, and I get 32. So angle 1 is equal to 32 degrees. Okay, now because the diagonal cuts it in half, it bisects it, angle 4 will also be 32 degrees. Okay, the last one, number 3. Again, because the diagonals are perpendicular, angle 1 is 90 degrees, and angle 3 is 90 degrees. Okay, now to find angle 2, I'll use the 35 degree. Now because this diagonal cuts this angle in half, this angle is also 35 degrees, and this is 90 degrees. And so angle 2 and 90 and 35 will equal 180 because this is a triangle, and the angles in a triangle add up to be 180 degrees. So I'm going to add 90 plus 35, and I get 125, and I subtract that from 180 to find the measure of angle 2, and I get 55 degrees. So angle 2 is 55 degrees. Okay, I hope that helps you understand the properties of rhombuses, meaning it has all the properties of quadrilaterals, it has all the properties of parallelograms, and the 2 additional properties are that the diagonals are perpendicular and that the diagonals bisect opposite angles.